Okay, so here's our lesson 3.3, solving quadratics. We've already done solving quadratics by square roots, which I'm going to touch on again, but today we're really going to work on factoring and quadratic formula as two other methods to solve them. So remember, solve means we're finding solutions, which is the same as finding the zeros, which is where it's going to hit that x-axis. And then I want you to also remember that x squared means we should have two solutions on everything we do today. So real quick, you should add to your notes these three graphs so that you see the differences. Two real solutions is going to be when a parabola hits the x-axis 2 times. And in 2 different places is generally what they intend there. One real solution, so think about it, it's hitting the x-axis, but only once. All right, that's going to look like, wow, let's pretend I can draw that better. There we go. All right, that's going to look something like that. And the idea is that it's only hitting right here once. So that's the same as when the vertex itself is a 0. And they call that one real solution. Real because it is hitting the x-axis. Another word for that is double root. And they call it double because that root that's listed there will be listed twice. And I'll show you an example of that here as we start working through. And then two imaginary solutions, that's this right here. When you talk about it's not hitting the x-axis at all, we know there's still two solutions. We just want to identify that they're going to be imaginary, which means they should have I in them when we actually work them out. All right, so this is just a review of square roots. I'm going to go super quickly on this because we've learned this. I just want to reiterate a few things. So remember, square roots, it's a quick method. Works when you can isolate x squared. That's the key. There's no additional x's in the problem. So this example works well for that. So we're going to get rid of our visitor. So subtract 10. That's going to give me 2x minus 3 squared equals negative 32. Divide by 2. X minus 3 squared equals negative 16. And then we're going to take the square root now that we have that isolated. Remember that when we take the square root to that other side, it gives us two answers. So the square root of 16 is 4, and the negative gives you I. And then this also gives you negative 4I. All right, so when we set up our two cases then, that's going to be x minus 3 equals 4I, and x minus 3 equals negative 4I. And then we want to just isolate x, so add 3. So our two answers are x equals 3 plus 4I and x equals 3 minus 4I. So that's an example of two imaginary solutions. So if you graph this parabola, it shouldn't be hitting the x-axis at all. All right, method 2 here is factoring. So notice that all of these examples, none of them would work for square roots because they all have an extra x in them. So you wouldn't be able to really get x squared by itself. So all of these are ones that if we can, we want to use factoring when they look like this because it's quicker than quadratic formula. So some notes, you need to change it to quadratic form. So that's ax squared plus bx plus c, which means you may have to move stuff. Or rearrange things, and we want to make sure it's set equal to 0 because we're looking for zeros. And then this is just a quick reminder, GCF we want to do first. Remember, bottoms up as a method, and we're going to see that. So let's focus in. We're going to do 3 quick examples. All right, so this first one is already set up for us. It's in quadratic form, and I know that because I've got x squared, and then the x, and then just a number. And it's already equal to 0, so I know I'm ready to start. So we're going to kind of ignore that 0 for just a minute and set up our factor. So right, we're looking for two numbers that multiply to give me 10 and add to give me negative 7. And if you think about that for a minute, you should get negative 5 and negative 2. So then I'm going to write my factors out. It's going to give me x minus 5 and x minus 2 equals 0. So this is just an equivalent statement if I factor it out. And now I want you to remember, you did this in Algebra 1, but just kind of think back. If two numbers multiply to give you 0, that means one of them has to be 0. That's the only way you can write a multiplication problem and it equals 0. That's called the zero product property. All right, so if we do that, and I'm going to write this out even though you won't eventually, let's give ourselves two cases. Either x minus 5 equals 0, or x minus 2 equals 0. And eventually you're going to see a shortcut here, but if I solve that, that's going to give me two zeros, solutions, roots, x-intercepts, all mean the same thing, right, of x equals 5 and x equals 2. So those are my two solutions there. All right, let's look at a similar problem. Okay, so this problem is not quite set up for solving yet. We need to move some things over. I need to get it in that quadratic form. So 2x squared minus 7x, I need to move this 5 to the other side. So I'm just going to write plus 5 equals 0. That way I have it set up correctly. So now same idea. I need to set up my puzzle. This is a bottoms up problem because I've got a number in the front. So 10 on the top, negative 7 on the bottom. This is exactly the same as the one before, and I did that on purpose so we wouldn't have to think too hard. I wanted you to see the differences. So if I set up my factors this time, remember since this is bottoms up, we have to divide. So this is x minus 5 over 2 and x minus 2 over 2 equals 0. Now I am going to take that other step to simplify this. So the first one, 5 over 2 doesn't simplify, so I'm going to bring bottom up. That's going to give me 2x minus 5. The next one, 2 does divide by 2, so that's just x minus 1 equals 0. So now we're going to apply that zero product property again and set up our two cases. Either 2x minus 5 equals 0 or x minus 1 equals 0. Now if I solve this, 2x equals 5 or x is going to equal 5 over 2. And on the other one, if I solve it, add 1 to both sides, x is going to equal 1. All right, so those are my two solutions. So notice that we picked the same numbers, but when we go to find the roots, these do have two different roots, even though the puzzle itself kind of looks the same when we're trying to pick our two numbers. So I wanted to make sure you saw that. Both of these are examples of two real roots or solutions, right? Because they don't have I in them, they're just real numbers, even though they might have fractions or negatives or whatever. All right, let's look at our last quick factoring example. Again, this is not in that quadratic form, so I'm going to fix it. 7x squared minus 28x. There's no number there at the end, so you can put plus 0 or just leave a blank, equals 0. Now, on this one, since this is not a trinomial or bottoms up, this is an example of GCF, so I'm going to go ahead and do that, take out the GCF. All right, so GCF here, I'm noticing that that should be 7x, I think. So if I take the 7x out, that's going to give me x minus 4. You can remember, think about that like you're distributing, right? Just mentally distribute that. 7x times x is 7x squared. 7x times negative 4 is negative 28x. All right, now we're on to that zero product property again. And I know that I'm there because there's no like squareds left in my equation. All the x's are broken down. So if I solve that, either 7x equals 0 or x minus 4 equals 0, which is going to give me two answers of x equals, if you divide 0 by 7, you just get 0. Add 4, so x equals 0 or x equals 4. All right, so those are your factoring examples for how to solve quadratics by factoring. All right, here's our last method, which is quadratic formula. I'm only going to do one example, but we'll get plenty of practice with this in class. All right, so the good thing about quadratic formula is that it always works, which some people just prefer to do it every time, but it takes longer. Like, it's a lot of work if you can just factor from the beginning. So I tend to only use it if factoring or square roots doesn't work, because those are both much quicker methods. So the quadratic formula is this big long formula, and hopefully you recognize that. There's the fun little Pop Goes the Weasel song, right? It's the one that I still sing even in my head to this day, like 15 years later, right? So it goes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And the things I want to point out to you, that plus or minus is what's going to give you two different answers, because for quadratics we need two answers. And this all over 2a, this fraction bar runs all the way from the negative b all through the square root. All right, so make sure that you recognize that. All right, so just to prove to you that this would not have been a good factoring problem. If I was trying to set up my puzzle here, this would have been bottoms up. That would have given me 8 on the top and 3 on the bottom, and there's no way to come up with two numbers that multiply to give you 8 and add to give you 3. So that's why this is not good for factoring. Okay, so instead of that, we're going to do quadratic formula. The first thing we're going to do is list out our numbers. So A is 2, B is 3, C is 4. If they had negative signs in front of them, make sure you bring them with each value. All right, and then we're going to set up our quadratic formula. So x equals negative b, so that's negative 3, plus or minus square root. I do the b squared in my head because when that's a negative sign, it has the tendency to mess you up. So I'm going to go ahead and write 9 minus 4ac all over 2 times a. Now the first part that we want to simplify is this part underneath the square root. So we're not actually going to use the square root part yet, just simplify the value under it. So if you use a calculator, you would just be typing in 9 minus 4 times 2 times 4, not the square root button. And I think that should give you 23. All right, so if I'm wrong, you can tell me in class tomorrow. All right, so this is x equals negative 3 plus or minus the square root of, and I just said it wrong, negative 23, all over, I'm going to go ahead and multiply that 2 times 2 and give myself 4. All right, now, sometimes this can get long because that square root right there is something that we need to simplify out, where we take out a positive root and then kind of do some work. And we'll practice with some of those together. But if we go ahead and break this, well, the only simplification we can do is take that negative out. So I'm going to do that. So this is x equals negative 3 plus or minus I square root 23 all over 4. And the only other thing that you need to see, that this is your final answer. It's just both answers have been written together. So if I break that up into my two answers, it's going to give me x equals negative 3 plus I square root 23 over 4, and x equals negative 3 minus I square root 23 all over 4. And that is your two imaginary answers for this problem.